simplify the radical expression, the cubed root of 81 g to the 5th h to the 7th over 3 h to the 4th j cubed. When we have something that's a fraction inside the radical, the first thing we want to do is see, can this fraction be simplified? And there are actually some places we can simplify it. 81 over 3, both of those have factors of 3 we want to cancel out. But then we also have h to the 7th and h to the 4th. Both of these have a factor of h to the 4th that are going to get canceled. So that's going to turn our problem now into the cubed root of 27 g to the 5th h cubed over now just j cubed. The 81 divided by 3 gave me 27, 3 divided by 3 gave me 1. Taking out 4 h's left me with h cubed. Taking out 4 h's on the bottom left me with just 1. And when I have 1's in the front, I don't have to write them. Now that my fraction is simplified, now I can go to simplifying rule number 1, that the radicand cannot be a fraction. So I'm going to break this apart so that my numerator is a cubed root and my denominator is a cubed root. Now that I have this, I need to go to rule number 2, that I cannot have any perfect square factors other than 1. But now, because it's a cubed root instead of perfect square factors, we need to make sure they have no perfect cube factors. So I want to break these apart and look for anything that's a perfect cube. 27 is actually a perfect cube because 3 times 3 times 3 is 27. But g to the 5th also has a perfect cube in it as well. I can break that g to the 5th apart so it becomes g cubed, a perfect cube, and then what's left over is g squared. So that's going to look like this. Now that I've got all of these, anything that's a perfect cube, I'm going to take its cube root and I'm going to pull that out front. So 3 cubed, and then the cube root of that leaves me a 3 pulled out front. G cubed, the cube root of that leaves me a g pulled out front. H cubed, the cube root of that leaves me an h out front. And then I want to make sure that this g squared just stays because it's not a perfect cube, so I'm not going to do anything with it. On the denominator, look at, I also have a perfect cube, so I need to take the cube root of j cubed. That's going to just leave me with j on the bottom. So my final answer, with nothing more that I can do, is going to be 3gh times the cube root of g squared, all divided by j.